Okay, so we are in Unit 5 and we are looking at the top of page 6. We just finished talking about chemical names and now we're talking about chemical formulas. A chemical formula uses the atomic symbol to represent the elements in a compound. In the formula, the order is the same as in the chemical name. So we're not really changing things other than we're going to use the atomic symbol rather than the chemical names. There's one major difference. The chemical formula gives us more information than the chemical name. It also tells us the ratio of cations and anions. So the symbol for each ion is followed by a number written as a subscript. This number tells us how many of each ion are present in the lowest ratio. So any ionic compound will have a certain number of cations and a certain number of anions. When you total up all of the positives and the negatives, the total is called the net charge. So remember, we talked about net charge of an ion or an atom earlier. Here we're talking about the net charge of a compound. So when we write an ionic formula, the net charge of the compound must be 0. Net charge of the compound has to be 0. The easiest way to determine the formula for a neutral compound, or something where the net charge is 0, is a method called switching the charges. So here's what you're going to do. You're going to write down the atomic symbol with the charge of each of the two ions. So take the number of the charge of the anion and place it as a subscript behind the cation. And you're going to leave out the sign. So the anion is negative, you're going to take the number and put it as a subscript behind the cation without the minus. Then you're going to take the number of the charge of the cation and place it as a subscript behind the anion. And again, we're going to leave off the sign, so it's without the plus. This is really important. The plus and the minus are not included in the subscripts. The subscripts tell us how many of each ion are present. They have to be positive numbers. We don't have negative numbers of atoms or negative numbers of ions. They're always positive. And so the signs need to disappear when those charges are switched to become subscripts. So the purpose of the subscript is to tell us how many of each ion are present. We need to make sure that they are in the lowest possible ratio. Lowest possible ratio. So here's the thing, you might need to reduce once you get a formula. And if the subscript would be the number 1, we're just going to leave it out. So I'll give you some examples and you'll see how this is going to work. And I'm going to do it with a few different colors. So yours can be just pencil, it's not going to matter. But I want you to be able to see where the numbers go. So I'm going to color code these. So let's say we have an aluminum ion and an oxygen ion. So the aluminum ion, it's in group 13. It's going to form a 3+ cation. and the oxygen is in group 16, it's going to form a 2 minus anion. So we have the atomic symbols, we have the charges. These are the first things that we need. So right under this, I'm going to write it again. Here's the Al, here's the O. Once you get the hang of these, it'll take less writing, but for now, it's not going to hurt to show a little extra work. So here's what it says for switching the charges. Take the number of the charge of the anion, that's this -2, and place it as a subscript behind the cation. So I'm going to take this 2 and I'm going to put it right here without the negative sign. And then here's my aluminum. We're going to take the number of the charge and place it as a subscript behind the oxygen without the positive sign. So what I have here is Al2O3. So Al2O3. And this is my final chemical formula. So you'll note that the subscripts do not have pluses and minuses. They're just numbers. You'll also note that for this one, my final one, this is what I'm looking at, there are no charges hanging around. Under no circumstances will we have a chemical formula that has subscripts and charges in the final neutral net charge 0 compound. So in the next example, we're going to look at sodium and chloride ions. So we're going to do the same thing here. What I'm going to do first is write these a little bit differently. So Na plus is the way we would write this, but really what it means is that it has a 1 plus charge. And same with Cl minus, it's actually a 1 minus charge. And so if you follow this, take the number of the charge of the anion and place it as a subscript behind the cation, this number would go right here. And the same with this one, the number of the cation goes here. And the way it would look is Na1Cl1, but the subscript is not included when it would be 1. And so our final chemical formula for sodium chloride would be this, NaCl. So the 1s are implied, the charges are completely gone. They're not written here at all. And this is our formula. Next, we're going to look at a compound that comes from magnesium and oxygen. So magnesium is in group 2. It's going to form an ion with a +2 charge. And oxygen is in group 16. It's going to end up with a -2 charge. All right, so same idea, 2 plus, 2 minus. So we take the number of the charge of the anion and put it behind cation. So Mg2. Try to spread this out a little bit. And you take the number of the charge of cation and place it as a subscript behind the anion. And so what you come up with is Mg2O2. But we need to make sure that these subscripts are in the lowest possible ratio. This is the situation we need to reduce. And so this is kind of like having a fraction of 2 over 2. In reality, it's just 1, it's the number 1. The same idea here. If there's 2 of these and 2 of these, in the lowest ratio, it's 1 of each. And so for this one, our final formula is MgO. A couple of other examples, we could have one that's magnesium and chlorine. So it's over here. The magnesium ion is going to have a 2 plus charge, and the chloride -1. So here's the 2 plus, minus is actually 1 minus. And so we would take the number of the charge of the anion, place it behind the cation. We are switching the charges. And so there would be a 1 here. This 2 is going to go behind the anion. And so we see that there's going to be 1 magnesium and 2 chlorides. And our final formula is MgCl2. All right, so we'll look at calcium and chloride. Calcium is in group 2, 2 minus charge. Chlorine, group 17, there's a -1 charge. And so we follow these same steps. That's plus. Switching the charges. We take this number and we put it over here. We take this number and we put it over here. And then we just rewrite it in a place where the charges aren't going to show up and the ones aren't going to show up. We're going to simplify it. CaCl2. That's how we're finding our formula. Okay, so we can fit one more in here. Let's talk about aluminum and nitrogen. So aluminum is in group 13. 13 minus 10 says 3 valence electrons. It's going to lose them and form a +3 charge. Nitrogen's in group 15. 5 valence electrons. It's going to gain 3 and form a 3 minus charge. And so same idea, we are switching the charges and dropping the signs. With this one, we come up with Al3N3. Again, this is not in the lowest possible ratio. It needs to be in the lowest possible ratio. And we have to reduce this one. And so, same thing like a fraction of 3 over 3, we are coming up with a formula of AlN. So this would be our formula.